Okay, cool. Let's just continue from wherever we left off last time. So basically, we were talking about a very simple theory in which we have radian, okay, radian as a new representation of angle, such that radian and degree is interchangeable. Okay, it's interchangeable. In which, as you remember, 360 degree is gonna be equivalent to 2 pi radian. Okay, 2 pi radian. Now, how are we gonna use this? Okay, to benefit our calculation is that I think if you remember, it simplified our calculation. How? Yes, if you remember, in the very common conventional mathematics, you have circumference of a circle, right, equal to 2 pi r. And similarly, if you have a circumference of a particular what is it called? Arc. If you have an arc length, again, a circumference is a whole circle, by the way. Circumference is a whole circle. Arc length is a specific edge of a pizza, the crust. Okay, yeah, like a pizza. So yeah, with that, we're gonna do what? We're gonna do a typical multiply by angle over 360 degree. And actually, we realize, if you remember, this whole thing this whole thing is actually basically the definition of radian. So why not we simplify everything? We just say this is gonna be S equal to R radian, which is theta. And that is a new formula you are gonna use. Now on, for every circular question, everything would use this formula. You will not you will never ever use the formula of 2 pi r again. You will just now start to use this new formula, which is S equal to R theta. And again, very simple, it's just basically radius and radian. Radius times radian, radius times radian. And also again, this is definitely given in the exam formula sheet, just feel free to refer. Okay, and this is again circumference. Just remember, S now on it represents circumference. Okay, cool. Now let's write this with some question over here. Cool. Again, I hope it should be very simple. Yep, nothing really technical, I would say. Yep, cool. So let's just try off with a few questions over here. Where's my calculator? It's okay. Let's just go through the step without calculator lah. Okay, I have the answer anyway. So yeah, for example, for the first question here, cool. For the first question here, we have example 3 from textbook. Example 3 for textbook. Okay, so again, very simple. Basically, just have to, like I said, S equal to R theta. So the radius times the whatever radian, you get the so-called circumference, the length of the outer side, the arc length. So yeah, this is as simple as 4.5 cm. Another one, 6 times 2 over 3 pi radian. Of course, this is very straightforward to be 4 pi. But again, remember, because a question given you, okay? Again, we usually accept pi. We accept to have pi in terms of radian. Pi radian is fine. But pi cm sounds very odd. Okay, pi radian is fine, but pi cm is very weird. No one want to see pi in terms of cm. That's no nonsense. Okay, so what do? We have to convert it to decimal. So just do 3.142. Okay, I can't press the calculator here, but I mean I have, but it's okay. Let me just get the answer for you. What's the answer? Wait. From 5 chapter 1. Okay. I believe you answered the textbook also lah. But yeah, so the answer should be very straightforward. Yes, just put in the whatever answer for So 12.57 cm. Okay, they take only 2 decimal places. Okay, that's it. Next one, simple also, but this one again a little bit tricky because you have to find this, right? You have to find this first and then you find the other one. So first of all, I think just a simple geometry you should know. This is basically 360 minus 140, you get 220. Okay, but again, like I said, we always operate with what formula? R theta. We always use radian, so we have to convert this into radian. Because we are all supposed to deal with radians. How do we do that? Yes, we're gonna again, if you remember, divide by 180 multiplied by pi. Okay, yeah, it's gonna give you how much? It's gonna give you something pi. Okay, let me do 11 over 9 pi. And again, you can keep it as pi for now. Because like I said, it is always okay to have radian. Okay, it's always okay to have pi in radian. These two things are very compatible. You always see pi radian. Okay, but later when you do S equal to R theta, you're gonna have a radius, which is 10 cm multiplied by this. Okay, now you cannot have the pi anymore. You have to convert it into 3.142 as given in the question. Then you are gonna have your new answer. So over here it will be 38.4 cm. Okay, 38.4 cm. Okay, that's it. Right, let's go through a few more questions. I think I'll just discuss all of this in one setting. Yeah, this one should be very simple. Yeah. Next one. Yes. Okay, so you have a radius, same radius for the whole circle, and then you have this radian, you don't know the other radian, but you know the you know the two outline of it. Okay, very simple lah. Okay, let's just focus on AB. First of all, focus on AB because it was given everything to you already. So very simple. 2.6 equal to 1.3 R. Again, S equal to R theta. Okay, so R is 2. Very simple. Then you want to find the radian of BOC, right? So again, simple. For BC, you have 1.4 equal to 2 radian. So the radian is going to be 0.7 radian. Yep, that's it. Okay, cool, nothing much. Yeah, okay, that's it for this question. Okay, again, feel free to pause it yourself if you need to copy anything, but yeah, I think it's quite simple for now. Okay, next one, let's move on to 1.2. Okay, 1.2, simple also. So we have, yeah, so basically this is arc length. Again, yeah, typically very simple. Okay, yeah, so just again, radius, radian, radius, radian, radius, radian, 13.2. Okay, cm. Radius, radian, 16 cm. Let me check the answer just in case. Okay, radius, radian. Again, don't forget 3.142 as given in the question. 3.142. Then you get how much? Let me just see the answer. Okay. Self exercise 1.2. Okay, yes. So yeah, it would be 13.09 cm. Okay, lastly, also very simple. Wait, MN. Now this is a bit difficult. You see, you want the MN, you want the NN. Okay, so what should we do first? Yes, we have to find the angle first because it is controlled by your angle. So how to find the angle? Very simple. NOM equal to a straight line, right? It's a straight line. Straight line minus 2.45. Okay, if you feel confusing, you can just simply convert this back to angle, degree. But of course, for now, I think is if you can have the idea. If you have the idea well, you should also remember that 2 pi is 360. So very simply, pi is 180. So this is basically pi minus 2.45 because like I said, 180 is a whole straight line, which is pi. Pi minus the other one, give you the other one. So that's it. Again, what is pi? 3.142 minus 2.45. Yeah, I need a bit of math. 2, 9, 0.692. Okay, radian. Yeah, and then I think also very simple, just have to do s equal to r theta. So this one multiplied by 10, you get 6.92 cm. Okay, yeah, that's it. Okay, again, I will not pause it. Just it should be very straightforward. Okay, so you can feel free to pause if you want to. Okay, yeah, next one. Two more questions. Very fast. Yes. Two more question. Okay. Okay, next one. Okay, simple also lah. Okay, so first of all, the radius. Like it says, measure arc length is 25 cm and then E or F is 1.284. So again, I think we are given one side and the other side. Try to find the angle first. So always find angle first. This is a chapter about angle. You started everything with angle, radian, right? Always find the angle first. 360 is 2 pi. Remember this? So yep. So how do you find E or F reflex angle? Reflex angle E or F. This is 2 pi whole thing minus 1.2484, and again don't forget the pi is given, you use 3.142 minus this. Okay, ayo, this is hard to calculate. Let me just use my form. Wait, so yeah, 2 times 3.142 minus 1.284, 5. This is 5 radian. Okay, 5 radian. And then what happened next? Yeah, basically the radius of the circle is supposed to be, again, typically s equal to r theta, 25 equal to 5 r, so r is 5 cm. Very simple. Okay, yeah. Then moving on, next one, they want to find, again, very simple. For EF, also just another arc over here, just use the correct, just make sure you use the correct angle. 5 times 1.284. Is it 284? Sorry. Yes, correct. What's the answer? 6.42. Okay, that's it. Yep. Okay, next one. Okay, so far okay. If good, let's move on to the next question. Okay. Last question. Last question. Let me just do it here. Okay, this is question 3 from the textbook. Cool. Value of, again, typically very simple. So first of all, what do we do? Find the other angle. No, sorry, wait. No, this one actually straightforward. Yeah, find the other angle first. We find the other angle first because you know that this whole thing is 5 cm. It should be very straightforward. So again, s equal to r theta, 5 equal to 5.7 theta, which give you theta as 5.7 over 5 equal to 1.14 radian. Okay, yeah. Then now you want to find okay, let's not use the same notation. Maybe you can do something like theta 1 maybe. Okay, yeah. So now how to find theta itself? Again, straight line is 180 pi minus 1.14. So 3.142 minus 1.14. So 2.002 radian. Okay, 2.002 radian. I think you don't need to round off. Don't need to just keep it at 2.002. It's fine. Okay, 3 decimal places is totally fine. Okay, lastly, also very simple. How to find PQ? PQ is basically this one. So again, use a correct angle. 5 times 2.002. So 10.01. Is it? Yeah, correct. 10.01 cm. Okay, that's it. Okay, that's it for this question. Okay, cool. I think yeah, that's it for this part of the video. Okay.